thank you everyone. Thank you for coming, and hope we'll have some nice energetic session today about a topic that is often overlooked by engineers and engineer leaders. We'll talk about engineer strategy. And engineer strategy can often be perceived by people as something very fluffy and abstract and not practical. And I'll tell you a story. How did we at Preply implement and defined our engineer strategy and how we operationalized it. It should be a very fun story of the last few years and also story where we are now. Before moving there, a few words about Preply and myself. As I said, I am Dmytro Voloshyn, CTO Co-founder at Preply. I was at Preply since the beginning. I was the first developer writing code. There were 3 of us. I was the only engineer writing code again. And Preply is a global marketplace where you can find a teacher who will teach you a language. And we started as a marketplace. And we became the world's biggest marketplace where people study languages online with humans. So really incredible growth, big offices in Barcelona, Spain, London, UK, and Kyiv, Ukraine. More than 700 people right now. And we are well known among language learners. We started as a marketplace, as a kind of our business model, but over time we also added a lot of amazing AI features. So we moved from being pure marketplace to adding really cool stuff where you not only have a teacher you study with, but you also have amazing set of features that help you to progress in your language learning journey. And here are some cool AI features that we built over the years. They are all AI-powered, very cool, very complex technical. If you want to chat about that, we'll be super happy to chat about our product more. But today we're talking not about the product, but about engineering. And to give you a sense what is the size and the scale of our engineering organization, we have 180 engineers. A lot of people like working in Preply. Very few leave Preply. We see like 3% regretted attrition, super low. We're an international team, 25 nationalities from all of the continents except Antarctica. And in average, people stay 3 years in Preply. So pretty solid engineering work. In a little bit more technical details, we deliver a lot. So if you take just through output, we merge probably how many, like 1,000 pull requests per month. A lot of people commit a lot of lines of code. Feels like a well-oiled machine where engineers actually deliver value to our customers. And we have pretty solid infrastructure. So like few thousand of pods, containers, whatever, the replica sets we have there in our infra. And at some point of time, a few years ago, I am like very technical person, but over time my role shifted to do more management. And engineer came to me and said, "Hey, Dmytro, I have a question to you, and it's a tricky one. I was curious, what is our engineer strategy?" So engineer coming to CTO asking, like, what is our strategy? And I'm like very business-minded, and I'm saying, like, our strategy is that we are winning. As a company, we are just like growing like incredibly well, like super fast, and our market share is insane. Revenue per employee is also like growing very fast. Like, that's our strategy. Our strategy is to win. And actually, when I started reflecting about that, it's kind of, yeah, we are winning, but if you dive a little bit deeper, will we be able to win over the next few years? Because if people ask you questions, what is your strategy? It's a question that implicitly means something is wrong. We lack something, we lack some clarity in a way to describe what is happening to me and what will be happening to the org over the next few years. And we dived much deeper to understand where we are at now, probably a year ago, and we started like diving into the data and different engineer metrics that we had. In Preply, we have A/B testing culture, and it's insanely good. It's almost like a religion. We launch A/B tests at scale, probably like thousands A/B tests per year, and each year we saw, starting from 2021, we saw small deterioration in the number of A/B tests that we launch. And it is a little bit surprising because our teams was growing during that period of time. So you see that like amount of engineers and product teams is growing, but a number of experiments is falling down. And if you index that by experiments per engineer, it's also going down. So yeah, seems like we are not producing much more features. Okay, what about pull requests per engineer? Pull request per engineer was like probably 100, 150 5 years ago, but now it's stabilized at 100, and it's also slowly going down. What about even weirder metric? What about lines of code? And you can argue that lines of code is a bad metric. All of these are very bad metrics to look at. If your manager estimates your performance by any of this, it is very red flag. It shouldn't be done like that. But if you take a look holistically at all of the different metrics and all of them go down, you can start smelling that something is wrong. And in our case, lines of code per engineer was going down, down, down. And one of the engineers even built a regression on top of that. And he said, cool, in 3 years, nobody will write a single line of code. Amazing company. Not so amazing for me, but let's see. What we found even more problematic is that we started touching old code. And this chart, by the way, this is one of the metrics that I love the most, because it shows you how many lines of code added per total lines of code in the project. Basically, what it says to you that engineers actively work with approximately 20% of the code base. So the 80% of the code, they don't touch it for different reasons. But the most obvious reason is the tech debt, that it is code that nobody wants to touch and nobody wants to change. So we're OK, seems like everything is bad. But is there any light in the end of the tunnel? Is there anything good if you dive into our metrics? Do we observe the same degradation everywhere? And we started diving into the data, and we found that in some of the projects that we launched recently, mobile app was started in 2019. And if you take a look at the same metrics in our mobile app repository, lines of code per engineer is going up. Mobile pull request per engineer is going up. It feels like something is good there. And we did some kind of, not interviews, but generally chatted with engineers asking why are you able to move in our mobile app much faster than in our mono repository with the main product? And everybody was saying look, mobile app is shiny, new, not much of a tech debt, and a really good architecture. It gives you a sign and some of the hints of what we'll be talking about later. Investment in architecture pays off, but realistically, we have some parts of our products that are newer, some parts of our products that are older. There is a fantastic talk from Martin Fowler about architecture, and it basically gives you a very strong idea that ideally, you want to have architecture of your product and a code base built in a way that you cumulatively add more features as the number of engineers in your company grows. So you add one more engineer, and you as an organization, you don't slow down, you at least keep the same speed. And he calls this design stamina hypothesis. And that's ideal state where you want to get at. And we really started thinking, how can we get to the state when we are able to scale our engineering org by adding engineers so we can produce more features, not like on the previous charts where you saw that numbers are going down. It's not only about architecture, it's also about processes, culture, and other things. But typically, a typical organization, as you grow, you are becoming slower. Is there a way to keep good velocity while you are growing? Because then, realistically, you can just double the size of your engineering team and you'll double through output of features. Sounds like a fantasy, but who knows? Sounds like an aspirational goal. And we also started reflecting what was happening in the company over the last 13 years. And we found out that if you think about engineering strategy, we didn't have one. We never put anything concrete to the paper. But we also made a lot of very smart decisions. For example, when we just started Preply, we focused only on two languages like Preply and Python and JavaScript. Later added typing. We also focused on React Native versus native development. We decided to go with AWS with cloud versus bare metal. We prioritized GraphQL over REST API. So we made such a good decisions that helped us to grow really fast. There was only one problem. All of these decisions, actually, they had some strategy behind them. But that strategy was implicit. It wasn't visible. It was made more based on intuition rather on some rational things. So we had a good sense, a good feeling of what are the right decisions to do. And as our organization grew, as we became more mature, this intuition became not sufficient to drive the next set of important decisions that we needed to make. And this kind of implicit strategies, I would just kind of do a little bit of archaeology and try to explain what it means that like basically we had few periods in our org, and when we just started the company, we were like very focused on MarTech. So we're doing a lot of MarTech engineering. We used engineers to help marketing to drive more traffic and customers to the platform. In 2018, we became much more product-oriented. So we introduced A/B testing culture, and we started A/B testing all of the product features. We focused on more product metrics like retention. In 2020, where COVID hit, we started to grow really fast, and we understood that we need to hyperscale our organization, and we used typical playbooks from Silicon Valley or have you built engineering org. So we became like classical US company, introducing different functions like engineer managers, engineer directors, changed the way how we deliver code and so on. And in 2024, we focused much more on engineer excellence because this is the year where we started noticing this degradation in quality that I showed you on the previous slides. And while we were in all of these different periods, this strategy was implicit, but strategies were implicit, but they helped us to make some decisions. For example, simple question, do we use microservices? When we are like very small, agile, and young company, no, we don't have time, expertise to do microservices, so like we don't do that. In 2018, answer would be different. Like, yeah, let's do some services. Let's A/B test if A versus B is better, and probably we can like adopt them on scale. In 2020, like we introduced some processes of writing RFCs, and my answer to developers who ask me, do you use microservices, would be like, write an RFC and we will see, because we're kind of doing everything properly. And in 2024, and where we are now, we came to the decision, no, it is a very intentional decision for us not to use microservices, and it's part of our strategy, about which we'll talk later. So bad thing is that while your strategy is implicit, you're making some decisions, but you cannot explain why are you making them. Another example is like to run through this kind of thinking process, like, should I write unit test? And again, when we were small, strategies not defined, no, we don't have time, expertise. When we were like in 2018, yes, because we don't need to do major migration of the database. In 2020, answer would be yes, it is a best practice, but now the answer is yes, because it's enforced by CI/CD, and it is a part of our strategy to have all of the right practices to be operationalized and automated through our CI/CD process. So we are now coming to the beef of the presentation, strategy itself. And everything that we had before, it was more like implicit feeling that how to do the right things that will help us win. But in real life, if you take a book definition of a strategy is a plan of action designed to achieve a major goal. It's a long-term approach of reaching goal by making smart decisions and allocating resources efficiently. So your strategy is to make some smart decisions and to allocate resources, also known as trade-offs. So you need to sacrifice something to achieve something. Unfortunately, that's how life works. And previously, we had a lot of smart decisions, but we didn't have this allocate resources part. So we didn't know what we are sacrificing to achieve some of the things. And we understood, yeah, it's nice, but we should approach building our engineering strategy in a much more structured way. Because previously, like if you talk with people in the market, you can ask them, hey, what is your strategy on hiring engineers? And the answer can be like, we hire the best engineers. It is neither a smart decision, because I don't see anything smart here. Everybody wants to hire smart engineers. But also, it doesn't present you a trade-off. Like, what is a trade-off? What are you willing to sacrifice? If you'll change it to something like, oh, we hire the best language-agnostic engineers by paying them 95% relative salary position in key hub locations, it's much better. It looks something like a strategy because it already has some smart decisions and trade-offs. Trade-offs are like language-agnostic, so you are expanding your talent pool, and also you're willing to pay more, but you also have constraints of having hub locations. So it feels that previous one was like hire best engineers, some fluffy statements. This one is looking more like a strategy. But if you think about building a strategy or defining a strategy, a lot of smart people already did the job for you to describe a process of how to build a strategy for a department, for a company, for yourself. And probably the most famous book for that is Good Strategy, Bad Strategy, which we used as a guidance for us. But also there is an amazing book, Crafting Engineer Strategy. And the fun fact, it got just released months ago, so it's very new, 2025, by Will Larson. And he's like celebrity opinion leader in engineering, and he writes amazing books, so strongly recommend build both of them. And also use your brain, because all of the organizations are built in different ways, and you'll need to adopt approaches that are described in books, or even from this talk. You cannot just apply what I'll be telling to you in your org. You need to adjust it to your reality. So building a strategy, how to take it from a more abstract concept to something more concrete. Mr. Richard Rumpelt, he defines strategy as a combination of three things. Basically, diagnosis, what is your biggest problem? Then guiding policy, what is a general line of thinking that helps you to overcome diagnosis? What helps you to win over your biggest problem? And then coherent actions. What are the actions and practical things that will help you to operationalize the strategy and actually implement guiding policy? By having all three of these, you will be able to say, hey, I have a classical strategy and it's very well defined and it clearly addresses the problem in a very actionable way. So starting from diagnosis, also again, returning to Preply, a company where I work at, we started diving much deeper. What is our biggest problem? And we did analysis. So you saw these charts where lines of code going down, number of pull requests is going down, everything looks bad, but why? The big question is why. And we started analyzing where are we as a company and what is happening. And from 2021 to 2024, we grew in 40% in headcount, but we also saw 20% more incidents. We saw that we implemented developer surveys, so we started asking engineers what bothers you the most, and we started comparing ourselves to the market, and we saw that engineers aren't happy. They don't like working with the code base. They don't like the developer's experience. They don't like the experience of CI/CD. And we started measuring, like, hey, why is that? Why do we see such negative sentiment and also speed degradations that we saw on the previous slide? And when we started diving into the data, we found that actually there are two main reasons. Also, it's applicable to our organization. It can be applicable to yours, but it's not guaranteed. But generally, two biggest things why developers feel that they are slowing down and the quality of the product is not as good and the quality of the developers' environments is not good. First of all, it's lack of deep focus. And I think this one is like a really thing that you can observe almost everywhere. When engineers have too many meetings, they are too much distracted on Slack, and they feel that I just don't have enough time to write code. And in our case, we did this, which is a data-driven approach of measuring how much time are we losing. And we found out very surprising fact that in some teams, engineers actually spend 15 hours per week on meetings. 15 hours. From 30, like 40 working hours, like more than 1/3 is spent on meetings. It's different by teams, but like we were like, wow, it's shocking. We connected Grafana to Google Calendars, analyzed everything again, and what we found again, the time between meetings is super small. So you can have 2 meetings and half an hour between them. It's not enough focus time for you to start writing code. If your unit tests run like 10 minutes or like 15 minutes, it's not enough time for you to just see a feedback loop from your results. And we implemented a lot of things to make sure that engineers can focus on what they can do the best, to write code. We reduced the amount of meetings, clustered them across few days, most of the meetings in the first half of the day, second half of the day, blockers in the calendar, improved there a lot. So lack of deep focus with right rules, right notification strategy on Slack, right collaboration with product org was not that hard to fix. And it showed like very good results. The other problem, focus on short-term results, is much more difficult and much more present in other orgs. Typical dynamic is that product organization in product companies is pushing for more results this quarter. Let's implement this feature, let's try to do this, let's stretch, let's try to deliver more. Even if the quality of the code or quality of the tech excellence is not good enough. I think everybody can relate to the fact when you have time pressure, you need to release code, and I don't have enough time to write unit tests or to cover it with end-to-end tests or add observability metrics to all of that I'm doing. Why is that happening? Because everybody has pressure to deliver more business value. And that is creating a lot of problems because the quality of the code base deteriorates and people lose faith in their craft. So about this focus on short-term results, what we observed is that this thing cannot be solved without collaboration with product. On this chart, between the pink lines, it was a period where we introduced product managers to our product teams and built much stronger product org. And you can see here that basically what ideal you want to have in your organization is a healthy tension between product and engineering, when engineering managers and engineers can say no. They can say, no, I will not merge this pull request, even though I have a deadline today. I want to end unit tests, or I want to write a more quality code, or I want to remove technical debt instead of taking one more Jira ticket with a feature request for this sprint. This is probably the most important dynamic to pay attention, to make sure that engineers feel safe and they feel that they can be proud in their craft. Otherwise, it will be like a vicious cycle of everybody's pushing for high results this quarter. Everybody is making trade-offs, approving suboptimal decisions, deprioritizing tech debt, deprioritizing engineering excellence. And also, if you don't fix this focus on a short-term results and kind of product engineering tension, there is a positive reinforcement loop. Who will get promoted next cycle? Engineer who delivered more product features or engineer who added unit tests? And I would say, in the last 4 years, where we saw this degradation in technical excellence in Preply, I would say the one who delivers more features because it impacts on the business. And we understood that that's a core problem. That's a core problem that we need to address, because if you always run for short-term results, you'll lose a long-term quality and focus of the platform. But you don't want to be winning only this year. You want to be winning the next 5 years. And these good things about business focus and this kind of short-term focus is that you'll have more features, you'll hit your business targets, and everybody from the business side will be happy, but you'll accumulate a lot of technical debt. You will see that risk of system incidents will go up. People will get burned out. Engineers don't like to work with bad code, with code not covered with tests. And they will lose faith in general quality of the system. On the other side, if you'll focus too much on fixing technical debt, everything will become more stable, and the cost of maintenance will be lower. Developers will be more productive, better code quality, but you also will be delivering less features, and you will lose some opportunity cost. So as a business, you risk of slowing down. And you also obviously will have a risk of over-engineering. And in these modalities, it is something that you need to make these trade-offs. Talking about engineering strategy and a guiding policy, you cannot have it all. You cannot have a candy and eat it too, as they say. You need to make some clear trade-offs to address this diagnosis. So when we did all of this deeper dive into why are we slowing down, we found these two things. So first of all, lack of deep focus, super tactical, can be fixed, not a hard problem. But focus on short-term results is much more kind of philosophical. That's something that needs trade-offs. That's something that needs described. We plan and diagnosis that in the way that we see it right now is that our velocity degraded from tech debt and long feedback loops. We plan to scale to 400 engineers in the next 3-5 years. We need to increase our compliance bar, and AI is basically changing everything that is happening in the industry. And this is our biggest problem. We need to focus all of the engineering resources and have our engineering strategy to address this. And we have some very good things in the company. We are very data-driven. I mentioned already A/B testing culture, but you even see in the way how I describe problems, we always talk about numbers and charts and things that we can measure. and we're very product-minded. So this is something that we wanted to preserve, where we were like designing our guiding policy. So after all of the iterations on, hey, what is our biggest problem, what is our diagnosis, we came up with a guiding policy. And when you first see it, you probably will say, oh, it's very abstract, it's like 12 or like 15 words. What does it actually mean? How should I apply it? And it's okay, because guiding policy is something that intentionally leaves you a space for interpretation. But actually, if you think about guiding policy to the diagnosis, it is very smart. And I'm saying that not because I invented that, it was like a team effort of me and my team, but actually it addresses all of the major problems and clearly presents trade-offs, and I'll show you how. So our guiding policy is front-load tech data foundations to win the 5-year business plan while meeting this year targets, accepting high dollar cost and narrowing product focus to enforce engineer excellence. If you are an engineer and you see this, you'll just say, OK, this is just words. I don't know what to do with that. So it needs a little bit of a reflection and processing from the org and operationalizing. But if you decouple it into 4 parts, generally, front-load take data foundations means let's hire to the platform teams first and make sure that we build right foundations before starting accelerating features delivery. When I say platform teams first, it means security, DevOps, SRE, developers experience. It addresses the problem that if you want to add more features in the future, you need to build the strong foundations first and then start accelerating, not simultaneously and not the vice versa. Win the 5 years business plan while meeting this year targets. It's clear prioritization of a long-term BP that, for example, if you are over-delivering on your business plan or this year targets, instead of taking more ambitious targets or ambitious features that you want to deliver, invest in technical debt because you have a buffer of resources that you can use right now. And accepting higher dollar cost is like you want to move fast, but you also want to increase quality. And there is like this famous triangle from product management, project management, is like you cannot have all 3. You need to select either speed, quality, or cost. In our case, it could be different in your company. What we decided to sacrifice is the cost, because we don't want to lose velocity, but we want to increase quality. And when you show this to people, they are like, OK, now it's much more clearer, because it's a very clear trade-off. And the last one is a narrowing product focus to enforce technical excellence. As I mentioned, we have very strong product mindset in engineering. And we felt that now is the time to focus more on technical excellence and give back a little bit of a product sense from engineering to make sure that technical excellence grows. These 4 parts from the guidance policy, we basically then converted to some very operational things that is called, we call coherent actions. And for example, for the first part, front-load tech data foundations, the first coherent action is that we rebalance resources to front-load platform capacity. And guidance for the teams for 2026 is that we don't hire product teams who inherit complexity from the product. Instead, we hire platform teams that will build the right foundations, fix CI/CD, fix developers' experience. We hire them in the first half of the year, and then in the second half of the year, we hire feature teams. Very simple, but provides a lot of clarity. The goal of engineer strategy is to provide a lot of clarity to organizations that first, you get less questions, and second, people are able to make decisions when you are not there. Written strategy helps you to enforce this clarity so everybody is on the same page. And the second thing is allocation rule. We started basically calculating headcount, how many engineers work in direct business impact team, how many engineers work on innovation, on security compliance, on platform. And we also introduced a tool which is called the X. It's engineering metrics platform. Big fan, strongly recommend to everyone. And we started measuring it more precisely, not on the level of headcount, but also on the level of Jira tickets. How many of the scopes that you deliver is actually product work versus innovation versus platform work and so on. So the first is like rebalancing resources. It's a very actionable and operational thing that we started doing to make sure that we focus more on a longer-term results. Second thing, as you see on this slide, win the 5-year business plan, it's related to this. If you want to win not just this year, but also the next one, you need to make sure that your code base is prepared for the next 5 years of growth. And the way that we gave guidance and operationalized that was evolution, not revolution. We reject massive rewrites in favor of evolving our modularized monolith. And it's very opinionated. And for engineers, it can be sometimes even shocking, because we are saying, for the next 5 years, we will be writing code into modularized monolith. We will not introduce microservices. We believe modularized monolith is something that will help us to move faster. And we will not have code freezes, because we need not only to win 5 years business plan, but we also need to meet this year's targets. Second thing, we move towards domain-driven design to map boundaries and ensure no code is left orphaned. So basically, we are piloting in some teams much cleaner contracts where the teams have cleaner boundaries of their code and their ownership, and we want to make sure that there is no parts of the product that is not owned by anyone before creating even new teams. And the third one is gatekeeping complexity. This is also very opinionated, but it also provided a lot of clarity to engineers. We don't introduce new services, new languages, or new technologies without an RFC or explicit approval from CTO, also known as me. And this provided people with clear guidance of what they should do. If you want to introduce something new, the only way you should do that is you write an RFC and you ask CTO permission. And on the picture, you can see our tech radar. And the problem, if you introduce too many technologies, languages, or other things, it becomes complex. You cannot focus on a long term if your product is complex. And to reduce complexity, you need to gatekeep it. We went with the way of restricting it in a very opinionated way and working really well. Third one is by immediate scale and growth with capital. And this part is related to this trade-off that I mentioned, cost versus speed versus quality. We sacrifice cost for the sake of quality and speed. And practically, what it means practically, when an engineer asking, okay, so what does it mean? Will I have a bigger salary or what? Operationally, it means that we do vertical over horizontal scaling. Very simple things. Instead of doing federation or replicas of your database, just buy bigger database, because you spend money, but you don't introduce additional complexity. Your incidents will be simpler, and you are buying scale with money. Second is buy over build. We use vendors for all commoditized functionality, which are not at the heart of our business. So by default, if you need to implement something, you don't build it internally, you buy it. And the third is a seniority premium, is that we accept higher dollar cost by focusing hiring of senior plus engineers in more expensive locations. So we are ready to hire senior engineers because they are faster to onboard and faster to deliver value. And they write more high quality code by sacrificing a cost that we pay a premium over that. And the last one is rebalancing the skill set towards tech excellence. So we established Engineering Excellence Dashboard, and it's also a part of a promotion process and OKRs process in the company. And there is a golden set of metrics that we work with, which is stability SLO, security SLO, postmortem closure, flaky test and test tests, experimentations, survivability, focus time, and tech depth. And that's our golden set of metrics that we measure by team, and we measure the impact and efficiency of the team not only by their product delivery, but also by this set of golden metrics. Second one, I already covered a bit, that we want to see more and more healthy tension between product and data. We don't want engineers to do work that is better done by product managers. And also we saw that there is an amazing value in establishing architect function that will mediate some of the very complex product decisions between product and engineering with a very clean process of doing that. And the last but not least is more standardization to enable creativity. As we change team setups and onboard more engineers, we'll need to enforce more standardization to ensure that process is cleaner. So 4 coherent actions to operationalize the guidance strategy, but also what we added here is that in a visual way, we want to shift from a short-term thinking to more like long-term thinking. We want engineering involvement to product to be slightly lower and focus time to be higher, and we want to focus more on technical quality. These charts is also like, not these charts, but like this picture is also about trade-offs. It is a very visual way how you can show to product managers or engineers where you want to be, where you are right now. So cool. We have big, grand engineering strategies that is, we front-load product and tech organization. We want to hit our 5-year business plan. We are ready to sacrifice cost versus quality and speed. But it's still very abstract. So engineers, if they come to you, they can say, yeah, I understand our strategy. I understand that we hire more senior engineers, so they understand implications of that. But they still lack clarity and guidance in their day-to-day work. The way we approach this kind of next level of explaining how to apply the strategy is that we introduced what we call local strategies. So the teams that I manage, my engineering directors, engineer managers, they have their own domains in the company. And they defined what does it mean, for example, for developers' experience to implement this strategy. So they have like a strategy on a last level of abstraction, more specific one related to developers' experience or strategy related to AI. And one of the really cool tricks that helped us to define this local strategy is what we call is to synthesize 5 RFCs. It's an advice from the book. So basically, we have RFC index where we document all of the decisions and trade-offs that we make in the company. So this is like request for comments about important technical decisions made by engineers. And one of the very workable approaches of refining your strategies from your RFCs is like, you take a look at them and you try to group them and you understand, is there anything in common between different RFCs that help you to make smart decisions? And for example, here we had RFCs related to Redis redesign, a refactoring of some service, refactoring multi-item orders, sunsetting Neo4j, introducing contracts in Django monolith. All of them had something in common. And what we had in common in all of these RFCs is that they all related to paying architectural debt. So basically, we had this grand architectural, grand engineering strategies that we introduced to the organization. But after that, on a one level lower, teams that are working with the tech debt, and we have a core teams which work with that, they defined a strategy, hey, but how do we actually, for example, pay technical debt? And there is smaller diagnosis, smaller guiding policies, different set of guiding actions of some of the local strategies related to paying technical debt. We have another strategy which is related to frictionless developers' experience. And it also has like a big problem, challenge, guiding policy, and coherent actions. And if you'll take a look around these coherent actions, they are much more specific in a way that it addresses like problems on a lower level of abstraction. They are much more practical. In the end, you'll have like your big strategy, how you manage your engineering org, but you'll have a different smaller strategies which are aligned with the grand strategy of how you solve smaller things in a different part of the organization. And some summary, the way I would summarize it is that unless you write down how you make decisions, what is the guidance, and what is your strategy, people don't know it. You can be lucky that some implicit decisions will be right, but much better is to write down your strategy, decrease ambiguity, and increase clarity for the org. Write in your engineer strategy, even if it is not ideal or as ideal as ours, it helps a lot. Second, strategy should address the right diagnosis and to be honest. Find the biggest problems that you want to address and fight it. In our case, this kind of deterioration of delivery, high-tech debt was the biggest problems that we wanted to solve for ourselves. Strategy defines tactics and operations, so you first need to understand what is the biggest problem, what is the guiding policy, and only then try to operationalize that. Don't jump into the solutions too early. Strategy without trade-off is wishful thinking. If you want to have really actionable strategy, you need to sacrifice something. You need to understand what you are willing to give. Best strategies help you to win by utilizing your strong sides. I already mentioned in our case it was data-driven approach, very high sense of product thinking in engineering. And if you don't talk about or if you don't measure it, it doesn't exist. It's advice for engineering leaders. You need to be talking a lot, socializing strategies in your engineering department, but also measure accomplishment of the strategy. You should have a set of metrics by looking at which, in a year from now, in 2 years from now, you should see, oh, are we progressing towards addressing this biggest problem, and are we doing the right things? Are they helping us to remove that problem? That's it for today. We don't have questions. sessions, but I'll be here for a few hours more, so super happy to chat about strategies and engineering overall. And I have two QR codes. If you want to pay to Preply, here is a 70% discount for your first lesson. It's an amazing discount, and you can start learning new language in Preply: Polish, German, English, Spanish. And we're also hiring, so if you want Preply to pay you, we have 100 engineering roles for the next year. So if you're an engineer leader, super happy to talk afterwards. Thank you all.